Congratulations, everyone. You have made it to the end of the trimester in Earth Science A, and I'm going to do a review here for the end of semester exam. So let's get started. This is Unit 7. We'll go over first all the different topics that you're going to see, and then I'll go through each one individually and give you the information you'll need to know in order to do really well on this semester test. Know that this is probably going to take two parts or two separate videos just because I'm covering all of these different topics and everything that is on the exam. Okay, so just a quick walkthrough. These are the ideas that we'll talk about. Uniformitarianism, it's one of the terms that we discussed when we talked about changes in the Earth and plate tectonics. We'll talk about the different types of plate boundaries and what happens at each of those, where convection cells occur within the Earth. So we have to look at the different layers of the Earth. We'll talk about the equipment and technology used to detect earthquakes, the criteria to determine if something is a mineral, and then looking at minerals, we'll examine the scratch test and the streak test. For rock types, you'll need to know each of the three rock types and how they are formed. You'll need to know the difference between chemical and mechanical weathering, how erosion takes place within a stream, so how the movement of water affects the deposit and way a stream will form. We'll talk about sun angles, what part of the Earth receive more solar radiation than other parts. What does the ozone layer do? So why do we have it? What's the purpose and what kind of function does it play? We'll look at the gases in the atmosphere and figure out what the most abundant gas in our current atmosphere is. We'll look at some different weather tools that meteorologists use and see what they measure. Going back to convection cells, we'll talk about how heat is transferred within the Earth and within other fluids. Look at the Coriolis effect and see how air moves around on our planet because our planet spins. Land and sea breezes and how changes in the temperature of water versus changes in the temperature of land cause these two different types of breeze patterns to form. Look at the definitions of temperature and density, the layers of the atmosphere, and that kind of goes back here to the ozone layer. So we'll look at what those layers are called. And then we'll discuss the difference between weather and climate, weather being the short-term changes or short-term events and climate being long-term, and then look at some severe weather examples, specifically hurricanes, and how they have a lot of low-pressure systems. So let's jump into it and see how much we can get through in the first part of our review video. The first is the idea or the term uniformitarianism. I know it's a really big word, but uniformitarianism is a theory that says that the changes in Earth's crust during geologic history have resulted from the action of continuous and uniform processes. To break that down, it just means the way that natural geologic events happen today, events like volcano eruptions, erosion, ocean waves, earthquakes, those type of processes happen the same way today that they did when the Earth first formed over 4 billion years ago. So we can understand the way Earth formed by just looking at the way these things happen today. There is no fundamental thing that changed about volcanoes. Volcanoes are the same now as they were millions and billions of years ago. So when we look at volcanoes, we can help understand how the Earth shaped from volcanic eruptions. And the same is true for erosion, for the way the oceans work, for the way earthquakes take place. All of this was originally kind of the idea formed by James Hutton, and then this helped shape the ideas of geology that we know today. So uniformitarianism, the present is the key to the past. By understanding the way geology works today, we can understand the way our Earth formed a long time ago. Okay, that moves us along to plate boundaries. We have three main types of plate boundaries that we talked about in class this trimester. The first is convergent. That's when plates move together, and we can see that over here. So we've got one plate converging or sliding into this other plate. Usually when this happens, you have one plate that is more dense than the other, and so the denser plate sinks below the less dense plate. We can have different types of plate collisions, so they can be two oceanic plates, two continental plates, or one oceanic and one continental. When the plate slides under the other, it creates a trench, so that's where that kind of fold happens between the two. When oceanic plates collide with continental plates, so that's two different types of plates colliding, we usually get volcanic mountain ranges. When two continental plates collide, we usually get mountain ranges, and when two oceanic plates collide, volcanic island arcs like the islands of Japan are formed. Those are different from hotspot volcanoes like the islands of Hawaii. So we can have oceanic plates converge, and that can create an island arc, so kind of a chain of islands, or something like the hotspots that we see in Hawaii are where a hotspot is kind of allowing lava to erupt out, and then as the plate moves, it carries away the islands with it. Okay, the second type would be divergent. So divergent, moving apart, the plates drift apart from each other. These create rift valleys or seafloor spreading. So we get these spreading centers, and then kind of magma will erupt here in the middle and create new land or new ocean floor where the plates have spread apart from each other. The third type are transform boundaries, and these are where the plates slide in opposite directions against each other. Earthquakes are a big event that we notice at these transform plate boundaries. So what's going on under the Earth's crust? First, we need to know what the different layers are. So we've got here layer D is the part that we stand on. That's what we call the crust. Underneath the crust, we have this kind of Play-Doh-like substance called mantle. It's really hot and it can move. So even though it is, it seems solid under our feet, it really does have movement taking place, and we'll talk about that in just a second. It is heated, and it turns into that kind of putty-like fluid because of the heat provided by the outer and inner core of the Earth. So let's take a look here. So if we kind of zoom into the section of the mantle, so that's this section here, we see that it is heated down here by the outer core. As it gets heated, we'll talk about those ideas of convection again in a minute, but convection is when the hot areas become less dense and they rise up. As they rise up, they are moving away from the source of heat, which is down here, so they begin to cool down, and that means they'll become more dense and sink. And so we get this pattern of movement, or this pattern of motion. This can cause tectonic plates on the Earth to move their directions. They can slide in different directions based on these convection currents that take place in the mantle. I just like this diagram here because it kind of gives a look at where the continents are. So here are the tectonic plates. We've got this mid-Atlantic ridge. So this is where one plate is sliding apart from another plate, and we have some plate interactions taking place there. Okay, we're going to just zoom in again and look at both the temperature and the mineral content of these different sections. So the crust is actually probably the thinnest layer. It's very thin compared to the other layers, but this is just a matter of perspective. So it looks thin on this diagram, but it's still miles and miles deep. The crust is anywhere from 0 to 1,000 degrees Celsius, and then if we just check the temperatures here as we go deeper and deeper, as you get deeper into the Earth, we're talking super hot temperatures, as hot as the surface of the sun. The mineral content also changes. So we've got lots of iron and nickel, iron and sulfur, iron, but now we have silicon and oxygen. We have silicon and oxygen here, and these are the elements that are making up lots of the minerals that are building up the rocks that we stand on. And then we have all these other elements that are sort of useful elements that we can mine or extract from the Earth for human uses. Okay, let's take a look again at what all of this fluid movement means. Changes in density are important for plate movement. So changes in the density of the mantle, as it heats up, it becomes less dense and it rises. And then when it rises, it's away from the heat source, so it cools down and becomes more dense. These changes in temperature and density cause convection. So convection is the cycling movement of material from hot to cold, from low levels where it's dense to high levels where it becomes less dense. And so this same thing happens in a pot of water, on a stove, and it happens within the earth. I'm going to take a pause here and move to the second part of our video.